All right, I finished my general announcements. Quick highlights. CFU 19 is retakeable until this Tuesday. CFU Wednesday will be passed back on Wednesday. CFU 20 will be passed back on Wednesday. It's only retakeable during this week. Students are reminded that we have a unit test coming up this Friday. Strongly encouraged to take that a day early if you don't expect to be here on Friday, as we are headed into spring break. Students are already given 2 minutes to complete the multiplication at the top of page 38. Was this page 38? Yes. Or 39. 38. Okay, good deal. All right, and we're going to get into the new topic for today, which is learning to combine graphs within a graph. Okay, now, how to combine polynomials graphically. Step one, I'm going to have done for you the entire period today. Since it's the first time we're doing this, I will be doing step one for you the entire period. Okay, but bottom line is, if you want to take one function, p of x, and you want to combine it with another function, q of x, there is a procedure that you typically want to follow. Step one is choose at least 5 x values. I've done that for you. In the future, it doesn't matter which x values you pick. You can pick the numbers you want. But I went ahead and filled in -7, -4, 0, 3, and 5. Now, step two is determine the y values of each function at the chosen x values. So, for example, for that first column, I'm just going to ask myself, look at the p of x orange line, and ask yourself, where is it at -7 and -4 and 0 and 3 and 5? So on the graph, you go to -7 and you say, all right, it's down here at -5. At -4, it's at -2. At 0, it's at +2. At 3, it's up here at 5. And at 5, it's up here at 7. So those are the numbers you're going to write down. You're going to write down -5, -2, +2, 5, and 7. Okay, I'm going to get rid of those lines because I don't actually need them, but please copy those values down. -5, -2, 2, 5. Now, the next column is actually going to go way faster because with the next one, again, I just need to ask myself, where is that line q of x when x is -7 or -4 or 0 or 3 or 5? And what's the answer for every one of those locations? It's just a flat line, folks. So what is it always equal to? It's equal to, I heard 0, but it's not at 0. If it was at 0, it'd be down here. It's at 2. At every single location, it's at 2. At -7, it's at 2. At -4, it's at 2. At 0, it's at 2. At 3, it's at 2. At 5, it's at 2. Everybody see this? It's just a big flat line, so it's always equal to the same number. Okay, it's just 2, 2, 2, 2, 2. That's what you're going to put here. That is the end of step 2. So step 1 is pick at least 5 x values. Step 2 today is going to be determine the y values of each function at those x values. Now, step 3 is, okay, let's actually do the math. Step 3 is combine the y values using the indicated operation. Now, in this case, we're being told to take p of x and add it to q of x. This is how we create the new column. Okay, all we have to do is add those numbers. So basically, we're adding 2 every single time. -5 plus 2 is -3. -2 plus 2 is 0. 2 plus 2 is 4. 5 plus 2 is 7. 7 plus 2 is 9. So you're writing down -3, 0, 4, 7, and 9. So filling in that third column is step 3. This is how you combine polynomials on a graph. You figure out where is this function, where is that function, and now let me put those numbers together using addition, subtraction, multiplication, whatever you're being told to use. Now we're on step 4. It says graph the result and connect all 5 points. Now, this part is in green. You are under no obligation to copy this, but I want to be very, very clear. When you're figuring out the new points, you are essentially done with this part of the table. That part of the table doesn't matter anymore. One column was one of the old functions. The other column that I covered is the other old function. It's the last column I want. And the x values do not change. That is probably the single most confusing part of this for students, that you do not touch the x values. The -7, the -4, the 0, 4, and 3 and 5 at the beginning of the chart, those don't change. But the new points are your final column. The -3, the 0, the 4, the 7, and the 9. That is how you get your new points. You look at the first column of your x's and the last column of the numbers you created. And those are your new points. So if I go to graph those, I've got -7, -3, -4, 0, 0, 4, 7, 3, or excuse me, 3, 7. I said that backwards, and 5, 9. And the directions are to graph those points and then connect them. That is your final answer. Now, I want to point out, you're not going to have a CFU on this week. We're not going to have a CFU on this stuff this week. There is no CFU this week. There's just a test on Friday. That test will include this type of material. So just take a moment to appreciate what's in blue on the screen. If you have what's in blue, you're going to get full credit because you showed your work of getting the points of the old functions, you showed your work of getting the new points, and you've graphed the new function. And notice all that really happened here was we took this line. Let me undo what I just did there. There we go. We took this line and we just added 2 to it. I mean, the other line is just always equal to 2. So when you take this line and you add 2 to it, all that happens is it moves up 2. That's basically what happened here. We took this line and we added 2 to the whole line. So it just moved up 2 spaces. Questions? All right, go ahead and turn the page. We're going to do this again. Now, on the next page, we are using the exact same 2 functions. We're still using p of x. So to save time for you all, I pre-typed the values. We're also using the same exact q of x, this line that's just always equal to 2. The difference is we are now doing p of x minus q of x. That's the only thing I've changed. We're subtracting instead of adding. So basically, I've already done the first 2 steps for you. Step 1 would be figure out which x values you want to use. That would be step 1. And you can pick whatever numbers you want, but I've already done it for you. Step 2 would be figure out the y values of whatever functions you're trying to combine. Now, because those are the exact same numbers we had on the previous page, I just pre-typed them for you. That way you don't have to write the same thing all over again. That's step 2. So I've done steps 1 and 2 for you. Step 3 is use the operation to create the new values. So all we're doing is subtracting 2, subtracting 2, subtracting 2 over and over and over again. Now, be careful when you have a negative number and you subtract 2, it creates a bigger negative number. So -5 minus 2 is -7. But when you get to the positive values and you subtract 2, they become smaller. So -5 minus 2 is -7. -2 minus 2 is -4. 2 minus 2 is 0. 5 minus 2 is 3. And 7 minus 2 is 5. That's step 3. Get your new values. Now we're ready for step 4. Step 4 is we'll go ahead and create the new function. Now, again, if you want to create the new points, you are completely ignoring these 2 columns. Those don't exist anymore. Those are the old points that you used to create the new points. So when you're graphing the new points, copy the x values. Again, you don't have to write this if you don't want to. That's why it's green. Okay. But then you also need to look at the last column for your x values, or excuse me, your y values. So for step 4, I'm going to graph those points. -7, -7, -4, -4, 0, 0, 3, 3, and 5, 5. And again, I'm going to connect those points. Okay. Now, in the first example, we added. In this example, we've subtracted. So basically, visually, all that's happened, let me ungroup that stuff. There we go. All that's happened is we took this line p of x and we subtracted 2 from it over and over again. -2, -2, -2, -2. So visually, all that happens is this line moves down 2 spaces. That's all that happened. We took this and we moved it down 2. All right. Now, there's one more example I want to show you all before I summarize what we've been doing, and then we'll look at 3 more examples and call it a day. Okay, so like I said, I think I can definitely get you at least 10 minutes at the end of the period to maybe work on your homework. All right. Third example. Once again, I've done the first 2 steps for you. Step 1, pick whatever x values you want. That's done. Step 2, look at the lines and record the values of that line at the x values you've picked. I did that for you with the first line, and I've done that for you with the second line. So I've done step 2. Now, step 3 is perform the operation that you're being told to do. Okay, so we need to do this in order to create the new function. So we're just multiplying the numbers. We're doubling everything. We're multiplying everything by 2. Okay, so -5 doubles to -10, -2 doubles to -4, 2 doubles to 4, 5 to 10, 7 to 14. Okay. Now we're ready for step 4, and that is we'll go ahead and actually graph the new function. Now, when you're doing that, again, ignore those middle columns. When I'm talking about the new points, all I care about is the very first column, because the x values never change, and the very last column, which are the new y values we've created. Okay? Now, in this particular case, I've got -7, -10, -4, -4, 0, 4, 3, 10, and then the other point is way off the chart. It's 5, 14. So I'll try to estimate where that'd be. It'd probably be like up there somewhere, but I put that in green because it's off the chart. You don't need to graph that one. Okay? And then again, just connect the dots with as straight a line as you can. Now, in this case, let me just go through the 3 things that we've done with this thing. Okay? We basically took this line, and in the first example, we added 2 to it. So it just moved up 2. In the second example, we subtracted 2 from it. So it just moved down 2. But in this example, we multiplied it by 2. And what that basically does is it causes it to be twice as steep. That's what multiplying by 2 does. I didn't mean to drag that blue line, just the highlighter. Why won't it let me grab the highlighter? Whatever. It just took it and made it more steep. That's what it did when we doubled the line. Oh, thank you. I no longer have this student. They're not even on my roster. Okay. Questions? All right, so on the next page, let me zoom out here. We're going to have a brief summary of basically what we've done. And then we're going to see 4 graphs, and we're going to need these 4 graphs not only to complete page 41 of your notes, but you're also going to need these same graphs on page 40 to do your homework. Okay. All right. So this says the function operations of addition, subtraction, and multiplication are defined pointwise. I'll explain what that means. This means the x-coordinate remains the same and the operation is performed on the y-coordinates, giving us a new point. So just to be clear, when we say pointwise, what we're basically saying is you look at an x value, you see what one function is doing there, you see what the other function is doing at that x value, and then you add, subtract, or multiply those numbers to get the new point. But through this whole process, the x value does not change. That stays. So you do it for each x value. You do it 1 point at a time for each x value. The x value remains the same. This is why it's called pointwise. If you're doing addition, you add for this x value, you add for this x value, you add for this x value. The x values themselves never change. Now, below are 4 graphs of polynomial functions. Assume the scale is by 1s and use these graphs to answer questions 4 to 6 in today's classwork, as well as questions 1 to 3 in tonight's homework. Okay? Go ahead and turn the page, folks. And just so you all don't have to keep flipping back and forth and back and forth and back and forth, I'll have you add labels to the pictures. That way you don't have to keep flipping back to this picture. That would be kind of annoying. Okay? So use the graphs provided on the previous page to complete 4 to 6 below. The graph of each function is lightly graphed for you, which you can use to create the graph of the final function. So just to point this out, from the previous page, f of x is this line here. So because you all don't have highlighters, please do this. Just write f of x next to that curve, the lower of the 2. Okay? Now, the other one is also from the previous page. That's g of x. Again, because you all don't have different colored highlighters, please just label this g of x. Okay? So that way you don't have to keep flipping back and forth to page 40. Now, I told you at the beginning of the period I was going to do step 1 for you all day. Step 1 is pick whichever x values you want. Again, I've done that for you today. So I just picked -2, -1, 0, 1, and 2. But now we have to do step 2 ourselves. We have to look at f of x and ask ourselves, what is the value of f of x at -2, -1, 0, 1, and 2? So if you look at this function at -2, it's down here at 4. Then it goes, or excuse me, -4. Then it goes to -3, then -2, then -1, then 0. So those are the numbers we're going to write down. -4, -3, -2, -1, 0. That's where that line is when x is -2, -1, 0, 1, and 2. Okay? So again, just making sure that's clear. At -2, this is down at -4. At -1, it's down at -3. At 0, it's down at -2. At 1, it's at -1, and at 2, it's at 0. So those are the numbers I wrote down. -4, -3, -2, -1, 0. Now that's only half of step 2. The other part of step 2 is looking at the other graph. So looking at the other line, at g of x, I need to know, where is it at -2, -1, 0, 1, and 2? Well, at -2, it's at 0. Then it jumps up to 1, then 2, then 3, then 4. Those are the locations at those x values, -2, -1, 0, 1, and 2. So we're going to write down 0, 1, 2, 3, 4. That's what's going to go here. Now we're done with step 2. Step 1 was get whatever x values you want. Again, I gave those to you today. Step 2 is write down the values. Now, step 3 is calculate the new curve. So we're going to look at f of x, and we're going to add it to g of x. So step 3 is to do this in order to complete this new column. So all we're going to do is add those numbers. -4 plus 0 is -4. -3 plus 1 is -2. -2 plus 2 is 0. -1 plus 3 is 2. And 0 plus 4 is 4. Okay, we are now done with step 3. The only thing left is to actually graph the new function. Now, when you want the new points, remember, I keep saying this, completely ignore these two columns. They don't exist anymore. Those are the old points. You used them to calculate the new points, but the new points are going to use the same exact x values with the new y values that you just calculated. So step 4 is let's go ahead and graph this. Okay, so I've got -2, -4, -1, -2, 0, 0, 1, 2, 2, 4. So this is our new line. Oh, I kind of wrote it into my g of x. I'm going to stop a little bit sooner just so I don't write it into my g of x. Okay. Now, I would imagine, I never know if I should be concerned when nobody's asked any questions. I'm going to be optimistic about it and assume that the reason nobody has asked questions yet is because everyone's comfortable. And if that's not true, you've got to speak up. Okay, you've got to ask me to slow down or re-explain something. Yes, ma'am. So one thing I was about to say was, I would imagine, based on the lack of questions, although I'm glad that somebody just asked one, that if I told you all to do the other two problems yourselves, many of you probably could. But like I said, my goal today was to get you some time on your homework. So I'm going to go through the next two examples myself, and then we'll be done for the day. Okay, now here's the next thing. This next problem, it uses f of x again. It uses that same exact function. So it uses that exact same line. So we can just copy those values from before. I'm just going to copy the same -4, -3, -2, -1, 0 that we had before because we've already done f of x. Now, the one we haven't done yet, okay, the one we have not done yet is this one from the previous page, okay? So this is, I'm going to label it k of x, okay? So please go ahead and label this f of x and label this one k of x, okay? Now, we have to figure out where is k of x at -2, -1, 0, 1, and 2. And this is kind of related to your previous question. So at -2, K of X is up here at positive 4. So I'm going to write down 4 for my first number. Now at negative 1, it's at, you got it, Tao, it's at positive 1. At 0, it's at 0. And then those values repeat, which is what happens with parabolas. At 1, it's back up at 1, and at 2, it's back up at positive 4. So the values of that curve at negative 2, negative 1, 0, 1, and 2 are 4, 1, 0, 1, 4. You got it. Okay? So that's what I'm going to write down over here. 4, 1, 0, 1, 4. Now, this is going to be the first curve we've seen today. We're adding a line and a curve. That's what the operation is. We're ready for step 3. We're going to figure out our new points, okay, by adding them together. By adding a curve and a line, the result is going to be a curve. So this is going to be the first curve we're creating today. Now, when you add those points, 4 plus negative 4 is 0. 1 plus negative 3 is negative 2. 0 plus negative 2 is also negative 2. 1 plus negative 1 is 0. And 4 plus 0 is 4. So now we're ready for step 4. Remember, with our new points, don't ever change the x values. This is why it's called pointwise. The addition, subtraction, multiplication we're going to do today is never done on the x values. The x values don't get touched. Okay? You do the operation for each point one at a time without changing the x value. That's why it's called pointwise. Now again, I'm going to ignore these columns for the new points. I'm just going to take the x values and the very last column. And those are the points I'm going to graph. So we've got negative 2, 0, negative 1, negative 2, 0, negative 2, 1, 0, and 2, 4. Now, it may be hard to see the curve, but one thing I might want to remind you all of is if there's a point at 2, 4, there's going to be another point over here. I put it in green because you don't have to create it, but having that mirrored point, that symmetric point, is going to help me draw this curve more accurately. Right? And plus, I think it makes it easier to see the curve that we're trying to create. That is your result. All right, and we're down to one final example. All right, now in the last example, once again, we have a function that we keep using over and over and over and over again. Okay, in this last example today, we're again using f of x. Okay, so please go ahead and label this f of x. The other function, which again comes from the previous page, I'm going to label h of x. H of x is this line right here. So please go ahead and label this h of x. Okay. Now, I can copy the f of x values. We've been using that same thing on this whole page. On this whole page, the f of x values have been negative 4, negative 3, negative 2, negative 1, and 0. So that's nothing new. Like, those are the same values we've been using this whole time. Okay? But for the h of x values, I need to pay attention to where is this function at negative 2? It's up at positive 3. Then it's at positive 2. Then it's at positive 1. Then it's at 0. Then it's at negative 1. So the h of x values are going to be 3, 2, 1, 0, negative 1. And if I'm going too fast on this, let me know. Now we're ready for step 3. Step 3 is figure out the new points. So to do that, all I have to do is multiply. Negative 4 times 3 is negative 12. Negative 3 times 2 is negative 6. Negative 2 times 1 is negative 2. Negative 1 times 0 is 0. And so is 0 times negative 1. Okay? So to create our new points, I'm just going to copy the first and last column. And again, please notice the new points I've written down are in green. You don't literally have to write them as long as you're paying attention to the fact that you're using the first and last column. Now, when you multiply two lines, they turn into a parabola. So this is going to be our second example today that results in a curve. Okay. Now, the first point is a little bit off the grid, so you can't really graph it. Negative 2, negative 12 will be like down here somewhere. And you don't have to graph that. It's off the table. But negative 1, negative 6. Then we've got 0, negative 2, 1, 0, and 2, 0. Now, I'll admit, this curve is kind of hard to see. But if you again, remember, any curve is a mirror image of itself. This point would also be here. This point would also be here. This point would also be here. Okay, if you imagine kind of reflecting those points over, it can help you graph this thing a little more accurately. So you don't have to do these. That's why I'm putting them in green. But those are 3 more points that would be part of this curve if you had them. And that definitely makes it a lot easier for me to draw a much better looking curve. Now, we're done for the day. We've got about 10 minutes left in class, a little less than 10 minutes. I would say enough time to get at least half of homework 71 done. Now, the one thing I would strongly recommend you do on homework 71 is label the graphs. Okay, you're using the graphs from page 40. Let me show you what I'm talking about. You're using these graphs to complete this homework. So what you might want to do, and if you want to copy it now, you could copy those labels, because I literally just got them from page 4. Okay? With that, we are done. Anyone watching the video, thanks for watching. Have a good one.